Hey, welcome back. Today we're going to be doing LeetCode problem 121, best time to buy and sell stock. Today's problem has a little bit different of a technique called the sliding window. It's a two-pointer system, but it works a little bit differently than a two-pointer system. So with that being said, let's go ahead and get started. All right, let's go ahead and read our problem statement. You are given an array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Alrighty, so let's go ahead and take a look at what the sliding window is going to look like, and let's go ahead and take a stab at our examples. So our first example, we have 7, 1, 5, 3, 6, 4. So just looking at this, our best day to buy is going to be 1, right? That's going to be our best day to buy because that's the lowest amount that we're going to be able to buy at this price. But we also want to take a look at when the best time to sell is. And when you think of these numbers in this index, you want to think of them as days, right? So index 0, that's our 0th day. Then this is the first day. This is the second, the third, the fourth, the fifth day, right? So when you think about days, well, we can only go forward. We can't go back, right? So if I'm going forward, then I can't sell in the past. That's just not going to work. So let's go ahead and take a look at this. So 7, we want to take a look at our lowest day. So is 7 greater than or lower than 1? Well, it's greater than. So we're going to move our left pointer over to 1. Then we're going to check the next one. Well, is 5 greater than 1? Yeah, it is. So we're going to go ahead and calculate our our max here, right? So our max profit at this current point is $4. Then if we go to 3, well, 3 is still greater than 1. And it's only $2 more, so then that's not going to work. That's not our max. We're going to go to 6. Oh, hey, that's greater than 5, and it's greater than our max at that point. And then we're going to go over to 4. 4 is not less than 1, and the profit is not greater than our max profit. So our max profit is going to be 5. All right, let's go to the next one. So here we have a sliding window again, but none of these are greater than are greater than 7, right? We're always going through. So the best day to buy is going to be 1, but we're never going to make a profit because all of these it's going downward, not upward. So because it's going downward, we can't sell at a profit. So hopefully that makes a little sense. The way we're going to implement this is we're going to implement a two-pointer system. But when we move forward, that is a little bit different than just a regular two-pointer system. So let's go ahead and read our notes here. We need to keep track of the first index, and we need to keep track of the next index, our left pointer and our right pointer. When do we want to move forward? We want to move our left pointer forward if the number at our right is less. And where exactly do we want to move that pointer? Well, we want to move it to our right pointer because we know in between that's going to be like the least there. So we also want to move our right pointer forward all the time, but we want to check our math when we're doing so. We want to check our max profit. Alrighty, let's go ahead and get this started. So I'm going to go ahead and declare my pointer 1, and that's going to equal to 0, and pointer 2 is going to equal to 1. And then I'm going to go ahead and declare a max, and that's going to be 0. And we're also going to be using a method in JavaScript called math.max. And basically what this does is it checks our max number within a set of numbers or an array of numbers. So you can see here that -1 is the greatest number out of these 3, and number 3 is the greatest out of these 3. All right, so let's go ahead and keep going. We're going to implement a while loop. So while pointer 2, because pointer 2 is always moving forward, is less than prices.length, well, we're going to do some work in this while loop. So what work are we going to do in this while loop? What do we need to be checking? Well, first off, what I'm going to do is I'm going to go ahead and let price 1 equal prices of pointer 1, because that's going to be our first price, right? Let price 2 equal prices of pointer 2. All right, so now we want to go ahead and check if our price 2 is less than price 1. What do we want to do? We want to move it forward, right? We want to move price 1 or pointer 1 to pointer 2. And what do we want to do with pointer 2? Well, we always want to keep it moving. So we're going to say pointer 2, and we're going to do our shorthand for adding 1, plus plus. Otherwise, what we're going to do is we're going to check our max, right? That's what we have down here. So we're going to go ahead and check our max against what we have now, our difference. So what we want to do is we're going to say let diff equal price 2 minus price 1. So now we have a difference, and we're going to check to see if that difference is greater than our max, current max. So we're going to say max equals math.max, and we're going to check max against our diff. And then lastly, we still want to move our pointer forward because we never know if that next point is going to be less than our pointer 1. So we want to keep going all the way to the end. And then at the very end, we're going to go ahead and return max. Alrighty, let's go ahead and run this. And yeah, this looks good. So we have both of our test cases passed. Let's go ahead and submit it. And that's great. So we ran it at 70 milliseconds and 51.8 megabytes. Alrighty, folks, that's all I have today. I hope you have a great day and a great rest of your week.